Now let's see how could we calculate integrals using these two. Here is an integral cosine n of x dx, in which n is an even number. In the case that n was an odd number, it is easy, but let's calculate it using this. This would be let's substitute this of cosine of Ig of this into cosine into the Ig, no, Ix, sorry, because this is cosine of z, so here we have x, Ix, plus into the minus Ix over 2, the whole thing to the n, dx. Now, this is, we could take 2, that would, let's write it, this would be equal to this to n over 2 to n. And this one is a constant, so let's take it here to the n. And here let's write it as 1 over into the Ix. 1 over into the Ix. Okay. And let's take into the Ix equal to something like y. So the integral would be y plus 1 over y to the n dx. Now let's use the polynomial extension for this. So this would be equal to 1 to the n plus 1 to n minus 1 times this plus 1 n minus 2 1 over y squared plus plus, since n is an even number, so we got an odd number of the terms in the extension. So that means that if we got odd number of terms, that means that we got the middle term. Okay, and what is the middle term? It is n half n by 2, n half times 1 over y to the n half, and this is 1. Okay, so this is 1. The middle term is this, plus, this means that equals to n factorial over I factorial times n minus I factorial. Okay, you may make already. So plus plus again this coefficient, the same coefficient, this time y squared times 1 over y and minus 2 plus let's write the rest here. And minus 1 plus 1 over y to the end. Okay, in this expansion, the first term and the last term got the same powers, okay, and the same coefficient, and the second term from here and the second term from here got the same coefficient, okay. Let's simplify it also. So here this is y to the n minus 2 here is 1 over y squared, so this is y to the n minus 4. This is this guy to n minus 4, 1 over y to n minus 4, and this is this guy to n minus 2. Okay, so as I was saying, the second term from here, from the start and from the end, which is this, got the same coefficient and same powers. For instance, here the power of this is n minus 2, and here the power of y is n minus 2. And again here the third term from the start is this, and the third term from the end is this. Again, same coefficient and same powers. So we could write it as now that would be equal to, take the first term and the last term, y plus, let's write it this way, 1 over y n plus the next one from here and the next one from the end, which got the same coefficients. So that would be y to n minus 2 plus 1 over y to n minus 2 plus the next one, this times y to n minus 4 plus 1 over y to n minus 4 plus, and we go this way, plus this this long term n half and here. Okay. Now let me y was into ix, okay, and the formula was cosine z equals to e2 iz plus e2 minus iz over 2. Okay, now here this is if you write it as e to the ix, that would be e to the mix, and this is 1 over e to the mix. Okay, so this is equal to 2 times cosine of mix. Okay, let me explain it a bit. This is into the mix plus 1 over into the mix again. So here instead of z we got mx, so instead of this c also we should have mx. Okay, so now this is mx. Okay, I multiply it by 2. Okay, so for every here and for the next term would be plus this times 2 cosine m minus 2x, and let's take to here cosine m minus 2x, and for this term that will be plus this times 2 cosine n minus 4x. This was the cosine or cosine of x to the n. So and we took the constant outside, so this would be equal to the integral of this, and they are simple cosine functions. Okay, the integral of this would be the sum of the integrals easy